have it over here, so I'm going to just read it off of my computer. Number 1. Okay. Number 1, find the zeros, right?
Mm-hmm.
What is that?
Find the intercept.
Very good. So actually, you don't want to, on your test, write that. So you're just going to do this. Find the zeros, right?
Yes.
In other words, you can also say factor, right? So if you had something like, right, you could factor it into the x plus and x minus situation, okay?
Yes.
Yeah, pretty simple, okay? Write that down for yourself in color because it's just something that you want to make sure that you can see, make sure that you can think about when it does show up.
Maybe red's a better color.
Yeah. Okay, find the equation of the line tangent to f of x, right, at a and b. Well, that means line means y equals mx plus b, right?
Mm-hmm.
Tangent means that
That's the derivative.
is our m. So we have y is equal to f prime of a x plus b. Or you could even just go get rid of that, and you can go...
Yeah. Oh, yeah, that's the form that I...
Write it down. It's just the fact that, again, I'm saying again, you know that definition. You know the definition. I'm not saying you don't. But because this is the world's most strictest math class that you will ever take, okay? But I'll tell you this. There's a reason it's strict. Because if you wanted to go work at Tesla and be an engineer, you think they would let you go by and not show your work?
Yeah, probably not.
Right? Elon Musk is like, oh yeah, I trust you, and you're not going to kill anybody with that.
Yeah.
Okay?
Makes sense.
So that's all it is we use the work as accountability for each other. And another thing is teachers, when they see you got your work, you got your answer and no work, they just assume you cheated off. Okay, that's how it works. Does this make sense?
Yes.
Now, notice as well, if we go to the next one, number 3, it's normal. So normal is just a negative reciprocal of that is now my m. Okay? Even, meaning if I plugged in a 2 here, it would be the same as what negative 2 is. Meaning everything on this side reflects across it. The easiest one you think about, you gave me an example. X squared is actually the even function that you want to think about. X to the 4th also works too. But what you just want to make sure is that anything you plug in as a positive is also the same thing as that negative. Okay?
Yeah.
And if it is a negative, it becomes that positive. And now the one that really tricks a lot of kids is this one, is your odd one is a double negative in here, okay? So you can even say negative here, but I just say put them both on one side. And be careful with that one, because the one that you're thinking, the x to the 3rd is 1, all right? Now what I want to be extremely careful about, because this is more of like a SAT type of question, is they'll ask you, is that even?
Yes.
Is that even?
Yes.
Is that even?
Neither of them are.
Very good, okay? Because the moment that you take your shift and you go up or you go down, they no longer reflect across exactly where the origin is. A little hint is the fact that this should equal 0, right? Once you plug 0 in there,
okay,
it usually will give you 0 because it goes through the origin, okay? Number 6, find the interval in which it is increasing. That is right where all you're really doing is the interval where f of x is increasing just means where the slope is positive. Okay? You're thinking, I think, concavity on that point, where it was positive to negative or negative to positive. Be careful with that. Okay? And so the interval where the slope is increasing.
Okay, what's this thing?
Right? Because now you're focused on the slope, and so that one increasing. So it's rare, and I don't think they will ever ask this, but how would you do it if it were concavity increasing? You would go, okay? I will make this quick chart for you here, actually. I love how this works is you start with your f of x, you derive, you get f prime of x, you derive, you get f double prime of x, right? So you can also say you got your distance, your velocity, your acceleration, right? Anytime you go down, you're just putting it over time one more time, right? However, the thing that I want you to think about here is when you look for, right, they're saying this is a value. This is that slope of the value. Okay? This is the slope of the slope of the value. And so earlier what they were saying is that the interval in which your value, the slope is positive, if they're saying where the slope is positive is this one. And so then also here we have this is concavity. If they say concavity is increasing, that would be being positive. Okay?
Okay.
So you can always go, I think of it as you should always have sets of 3. This, to find out information about this, you have this and this. To find out information about this, you have this and this. If you wanted information about this one, or the last, right, you go 1 and 2. You'd actually have a 4th derivative. It's just the number of x powers that you would end up having. Okay? And also just a little hint into the future, a lot of stuff in our world all ends up with sine and cosine in it. So it would never end up deriving everything out of it. It would always fluctuate. Okay? Number 8, minimum value of a function.
So you have to check where it's, well, you have to check where it's, yeah.
Concavity, right? Now, on our double derivative, here's my way of helping you memorize it. It took me a while, too. Concave up, concave down. Concave up, concave down. Concave up is a positive double derivative. Concave down is a negative double derivative, right? This is a minimum, though. You can think positive is happy or going up. Negative is down, unhappy. However, the happy is a minimum while the unhappy is a maximum. Okay? So in this situation, if they're asking you for minimum value of a function, right? You're going to do that with that.
Yeah, and then see which side
Or
is
C,
positive or
C,
negative.
C, right?
Yeah.
Go ahead and write those down. Do you guys have any questions about anything you see?
Okay, yeah.